Hello everyone, my name is Thiago and today I'm going to present a paper called Many Objective Search-Based Selection of Software Product Line Test Products with Nautilus. The idea today is to show some basic foundation about the VT-SPL problem and show some implementation aspect of this extension. And at the end, I'm going to make a quick demo about the tool. Variability tests of software product lines, or just VT-SPL, address the selection of products derived from SPL variability model. In our context, our SPL variability model is a feature model. The tester needs to test the feature model, but to this end, the tester needs to test all possible products that can be derived from this for a given feature model. However, we are not able to test all products because depends on the size of our feature model. We are going to have an exponential number of products to be tested. This is not doable in practice. So we need to select the most representative product from this set of products. We can find on the literature papers addressing this problem, considering several techniques, and most of them used to use mono, multi, and hyper risk optimization algorithm. Since they address this problem using search-based optimization algorithm in general, the papers try to optimize several objectives at the same time. For example, number of products, pairwise coverage, mutation score, feature importance, and so on. These algorithms try to find the Pareto front. It means the best solution considering all objectives being optimized at the same time. Choosing the best set of objectives is a hard task for the tester perspective because some objectives may be redundant or conflicting. In some cases, the testers have their own preference about some objectives. At the end, the tester needs to analyze a huge set of possible or good solutions. Then, a tool in this context is fundamental because we need a tool that support this decision-making process. So, in this paper, we are introducing Nautilus VT-SPL. This extension is an instantiation of Nautilus framework, and this one allows to the testers or support the addition of new problem instance, search operators, optimization algorithm, guided or not by the user preference, and so on. Extensions, the testers are able to, for example, experiment different objectives. At the same time, they can evaluate different optimization algorithms such as reference or preference-based algorithms, and the user is able to easily analyze and select the best solution. Regarding some implementation aspects, Nautilus framework has basically three main models: the Nautilus Core, Nautilus Plugin, and Nautilus Web modules. The first one is responsible for providing the base components to the other modules. The second one is responsible for providing to developers some components to be extended. For example, new algorithms, new search operators. And the Nautilus Web is responsible for showing the user interface to the testers. The last one is the extension for Nautilus. It's called Nautilus VTSPL. This is the plugin where we are releasing a set of problem instance to be tested and a set of objectives to be optimized. In this version, we are releasing 7 objectives. The first one is number of products. The second is alive mutants, followed by uncovered pairs. The next one is the product similarity. We want to reduce the number of similar products in this selection. The product cost, we are trying to reduce the cost of the selected products. And unselected feature means we want to select a set of products that address all features available in the feature model. And the last one is an important feature, so we want to select products that has the most important features. These 7 objectives, we implemented this in a way that we want to minimize all of them at the same time as a default. And now let's see a quick demo about this extension. This is the main screen of Nautilus. You need to type your credentials here. Since everything it's okay, you can visualize the home screen of Nautilus. Here you have access to the list of executions that you performed before, and if you want, you can just push the new execution button to create a new execution. In this screen, you have a list of available problem instances where you can pick one of them to optimize. If you want, before optimizing, you can go and select one of them to visualize the information that the instance provide you. So for example, for J instance, we have here 14 features. We have 68 products to be selected, and we have as well the pairwise and the mutation coverage for this instance. Since you are done, you can just go ahead and push optimize button. This screen, you can set the parameters. For example, you can set the algorithm that you want to use. You can define the population size. You can define the maximum evaluations. You can even define what is going to be the search operators that your algorithm is going to use. You can select which objectives you want to optimize, and you can define some preference for some or all of objectives that you are optimizing. So we are going to set the population size as 100 and the max evaluation as 100,000. And we are going to use the NSJ2 algorithm. So you need just to click on execute button. So we have here access to execution queue where we can see the progress about the execution. Since this is done, we can just go ahead and click on the title and we have access to the Pareto front. In this screen, you can explore the Pareto front. You need just to hold your pointer on the top of these solutions here, and if you want to visualize one solution, you need just to click on it and the solution will come up, and you can see in this solution, for example 99, it has 4 selected products, and this side you have access to the information about the objectives. You can go back and select a new solution like this one, and if you are interested in this solution, you can just tell to Nautilus, I like it, so that let me push the select button. You can do this for every solution that you want. Once this is done, you can compare the selected solution from this Pareto front to others just pushing the compare button. And here you can compare the selected solution among different Pareto fronts generated by different algorithms. To this end, you need just to push the compare button and you are going to see the selected solution for every different Pareto front, and we have information about the hypervolume and IgG metrics that are widely used on optimization algorithm, optimization field. So for conclude this presentation, this paper introduced a Nautilus extension for the validity test for software product line. This extension allows the testers to choose or configure the objectives to be optimized or even select or test different optimization algorithms. The idea is to offer to the SPL community a tool that makes the use of optimization algorithm more accessible for SPL engineers. As a future work, we intend to implement more objective functions and optimization algorithm and make some experiment with different and new instances of this problem. So the source code is available on GitHub. Thank you so much.